Number 1. 524 again. The blank of a triangle has endpoints that are midpoints of two sides. What is it?
Mid-segment?
Mid-segment, yep. Number 2, a blank is a comparison of two quantities using division. A ratio, right? Because a ratio is just a fraction. That's what that means. Number 3, if A is congruent to X and C is congruent to C, then triangle ABC is similar to triangle XYZ by the angle, right? A blank is an example of a similarity transformation. What did we work with this chapter? Dilation. Okay. 6, the ratio of lengths of two corresponding sides of two similar polygons is a, now we have a proportion. Right? Number 7, a blank is an equation stating that two ratios are equal. Oh wait, this should be proportion. 6 should have been scale factor, sorry. My fault. 6 is a scale factor, 7 is your proportion. Okay? Any questions there? Obviously, we won't have a vocabulary section. I honestly think I should start that just so you actually take the vocabulary a little serious.
I think you should next year.
But I think we should next chapter.
Next year.
Number 9 and 10 are the first parts. Obviously, we're just solving a proportion again. So as long as it's set up, remember we're just looking diagonals, setting the diagonals equal to each other. Okay? So do you need to see either 9 or 10 on the board?
No.
Everybody okay? Even though that they have a quantity instead of just a number? I don't believe you have to do the next kind, the ratio one.
What, if it gives you 3 lengths,
Yeah.
or if it says like 14?
No, you don't have to do that.
No 14?
But there is a ratio one, meaning, no, you don't have to do that. What does the little 5 to 8 to 10 mean in 13?
That's just the ratio.
The size.
Those are my ratios of the sides, right? So if I was given something like that, if it's the sides, remember I'm always going to link it to perimeter.
Yeah, see.
If it's the angles, then I'm always going to set it equal to 180, okay? There's one kind of like 13, but not really. Same kind of respect.
Didn't you just put 5x plus 8x plus 10x equals 2
Yes. And then make sure you answer the question, okay? This one said find the length of the longest side, okay? 15, determine whether each pair of figures is similar. If so, write the similarity statement. So in this one, I have to make sure of what?
Test all sides, right?
That's where we missed on number 6, or whatever it was on the quiz.
You have to test all sides.
You had to look at the sides, and they have to be the exact same thing on every single side. So just because you did 2 of them, you always got to check the 3rd, or in this case, the 4th. Okay? Now, obviously, in this one, you really only have to test 2 things, right? Because it's a parallelogram, it looks like. Okay? So we're doing what? 16 over 6 and setting it equal to 10 over 4. So you either just reduce it as far as you can, or you just simply divide it and look at the decimals. Okay? The biggest thing in something like 15 and 16 would be to make sure that you are looking at it in the right way. So obviously, see how the 1 arcs and the 2 arcs, that's a really important part of that problem. And then if it's a triangle, that you make sure you go in the right order, or you're looking at the right angles and sides. So, does 15 work?
Yeah.
Is 16 over 6 the same thing as 10 over 4?
Yeah.
Yes.
Try again.
16 over 6.
No.
6 over 7. Oh, like you meant like actually equation wise?
Yeah. What else
What
would I
are you
do?
thinking? I thought it meant like, is it like in the same, like,
Oh, it
same
is.
spot?
Oh, like
The
fixed.
same.
No.
Okay.
So does 16 over 6 equal 10 over 4? No. And the second one, number 16, are those rectangles similar?
Yes.
Because remember, are all rectangles similar?
Yes.
Are all rectangles similar?
No.
No, right? I could have a really skinny rectangle, right?
Yeah.
Or I could have a square,
Yeah.
okay? So basically they're saying is 15 over 10 the same thing as 9 over 6, and in this case they are. So then you need to make sure, now this one's kind of a weird example because you could really honestly say the similarity statement was a lot, or a couple different things, right? Because you could go PQRS to WXYZ, or you could really switch it around and say QPSR, or you could really flip it upside down and say SRQP. They're all the same kind of thing because of it's being a rectangle. Does that make sense what I'm saying there?
Yeah.
Okay, so 17, the two triangles in the figure below are similar. Find the value of x. So if they tell you they are similar, then all you're going to need to do is set up a what? A proportion. Right? You're just going to set up a proportion. And again, the most important part of this is we would say that they are similar by what?
Or side angle side.
Side angle side, right? And when we say side angle side with similarity, we know that the corresponding angles would be congruent, but then the sides would actually be what? Proportion, right? That's how the difference between this side angle side and the side angle side we did previously. Okay, turn the page. Then we get into our special triangles. Okay, so we had, I think, 3 different things with special triangles, right? We had an altitude, which was from a vertex to the opposite side, making a 90-degree angle. We had a angle bisector, which obviously just bisects the angles, but we actually had 2 different ones for an angle bisector, right? We had where it was 2 different triangles, or we had it to just the one triangle. When we had it to just the one triangle, it was the side of the triangle to the nearest side that it was cut into. You know what I'm saying there? The little piece. So if we had something like this, we have this as our angle bisector, and they show that by doing this. Then we would do X is to Y as
Oh, those were the 5.
Z is to A, right? Because they're the closest together,
Those are the 4 different theorems that we have for them.
okay? So that was the second one. The other one was just saying that then we had 2 triangles that were similar, and you could do the angle bisector to the angle bisector, and then any one of the sides, okay? And the same thing happened with our altitude that we just talked about. The last one would have been a median, right? And what was a median?
Middle.
From the vertex to the opposite side, cutting it in half. So essentially it makes a midpoint, right? So it says in 19 through 22, determine whether the triangles are similar. So if I'm looking at this one, we're kind of going back, and I guess we haven't got to that section yet, but we could have, by the shapes that were given. In 19, would you say that this is, or those are similar triangles?
No.
Everybody say no?
Yeah.
Everybody's wrong. So, in 19, how are they getting this? If you take that little guy up in the corner and then flip it around, they're gonna,
Whole triangle.
okay, so then you got, what numbers are we putting together?
You're taking the whole one side.
No, just.
You take the whole side.
to me, I would do 5 is to 10,
Yeah.
right? As 7 is to 14.
Which one do you want?
19.
Oh, I see what you're doing.
You would just do 5 to the whole thing,
Oh, I see what you're
and then you would do 7 to 14 with the whole thing on the other side. So you're taking one side.
He added them all together, Gabe. He added two sets.
This was what they gave me,
He added
right?
these two
This is
together,
7,
and these two together.
this is 3, this is 5,
9.
and this is 9. So basically, I'm taking this one, this little guy right here, picking it up and flipping it this way. So to me, I know it's not, but this hypotenuse, I know it's not a hypotenuse because it's not a right triangle, but this longest side right here is opposite of this whole long side.
Which is, yeah.
So then 7 over 14 is my 1, and then so basically I'm doing the left-hand side of the little triangle, and it's got to go in the same spot as my 7 because it came from the same triangle. And then the opposite side of that, or the corresponding side, would be that whole 10. And then those two do make a proportion because they're both above that. Okay, so that was kind of interesting. So, and the next part of this is, don't say anything out loud, let everybody have a chance to think. What is my similarity statement? Okay, so again, this is important. So they have A, B, C, and what? D and E. Okay, so this is where you gotta make sure of this. So I know that my angle A is congruent to itself, right? And then I know that my hypotenuse has to be in my hypotenuse, which I know it's not a hypotenuse, but it's the easiest way to explain it. So what is my, whatever my similarity statement is, I'm gonna pick one of my triangles, either the little one or the big one, and I'm gonna write that triangle, and it doesn't matter how I write that triangle, right? So I could say ABE.
Similar.
Somebody else could say EAB. Somebody else could say AEB. Okay? All 3 of those are the right answer. But then we gotta match it up. So A has to go in the same spot because they're the shared angle. And then B has to be, should be D, right? And then C should be the last one. And then obviously your letters would change if you did it in a different order as the first 3. They just have to match up. Everybody good with that? So that's actually a really, really good problem. Okay? How about 20?
Why would-
20 is a little,
Why wouldn't it be ACE?
Because of the hypotenuse.
because this A to B is the long backside, and that's my long backside of the big triangle. So D and B have to be in the same spot. This right here is getting flipped over.
Gotcha.
Okay, so CD would be equal to 80 in this?
C, D, they're not equal.
So wait, if you
They're
like,
similar.
so if
CD is the same thing as BE.
Okay, so if DA was the hypotenuse, wouldn't that make AE also the hypotenuse?
DA is not the hypotenuse. The hypotenuse of the big one is AC
And then AE is your big side.
AE
And then AE is also the hypotenuse.
of the small
Oh,
So if you like rotate it 30 degrees, wouldn't that make AB equal to CD?
one. No. This right here, to me, this side right here is the same as this side right here.
Okay, so you're just like flipping it over.
I'm taking this and flipping it, yes. Yes. And you get that by the numbers. If you would have done what you were saying, the numbers wouldn't have worked.
Yeah, that's why I was somewhat confused.
Right? Okay? That makes perfect sense, but yeah, but that's what it is, okay? And then obviously it's not a hypotenuse,
Wow, it's not
just because it's not a right triangle. 20, a little bit more straightforward, right? So again, now this one you actually probably have to punch into your calculator though, because 5 over 7.5, you gotta put it into your calculator because you probably don't know that decimal. But then you're just seeing if it's the same thing as 2/3 or 2/3. So it's 5 over 7.5, 2/3. That's basically what they're saying. Okay, so then hopefully your similarity statement's a little easier on that one, right? And again, it doesn't matter where you start, you just gotta make sure you match up the spots. Okay, how about 21?
It's a new.
You put 42 and 58 6/4.
Does 42 plus 58 equal 90? Yeah?
No.
It's 100.
So are they similar?
No.
Nope. 22.
We gotta put action
Do
stuff.
alternate interior.
Yeah.
So does 22 work?
Yeah.
You can make it work.
Because why?
Alternate
Well,
interior and vertical. linear
Alternate
horizontal.
interior and vertical. Can I do both alternate interiors just?
Yeah.
Yeah.
Sure. Right? Or I could do the vertical. So this one's probably a little bit weird too when am I just taking it and flipping it over? No, I'm probably taking it over and rotating it also. Kind of what Riley was talking about on the other side. So to me, V and R have to be in the same spots.
Let's figure out just some of that.
Yeah.
Because it'd be too easy if you just flipped it, right?
Got it? So V and R have to be in the same spots. Obviously, T have to be in the same spots. So that leaves S and U in the same spots.
I mean, how are you gonna know? I mean, you're just gonna assume that they're just gonna rotate and flip it?
How do I know? Because if I just flip it over, it's not gonna fit.
True.
It's not the same shape. So I gotta flip it and rotate it.
I should.
You know, we are do the same.
Right. Everybody good with 20 or 19 through 22? Those are actually really good examples. 24, then we get into the parallel lines and proportional parts. So again, this is just making sure that if you have parallel lines, then you're putting the same spot to the same spot, right? In your proportion. And really, you can kind of manipulate it however you want. So in 24, you just have to make sure that you're looking at the same spot and putting it in the same part of the fraction. Everybody get at that one? Same thing happens with 25, right? 25 is kind of interesting though. Is it okay if I just do 8 to 10 and 18 to x?
No. You're gonna have to do 8 to 10x, I think.
8 to 10 and X over.
Yeah, there you go. Yeah, 26.
So I'm gonna do, I should have to do, I can still do 8 to 10, right?
Yeah.
Because that's okay, because that's my little side to little, or the hypotenuse. And then I'm gonna do what?
26 over 10.
8 have to be, is it 10x?
Yeah.
10 plus X.
10 plus x, big difference, big difference, okay? X plus 10 and 10x are way different.
Why are you doing the total?
Yeah.
Oh, it's not a whole triangle.
Right, because I gotta look at the specific parts of the triangle. Okay, and then we're ready just to do our proportion, right? Remember, when I'm doing this, I'm distributing. Put parentheses around that quantity and distribute through there. Everybody good at this? Or do you need to see the math?
Where did the 26 come from?
You have to add the two sides.
Because on the left-hand side of
You
what
gotta
it
add
was,
these two together.
I gotta add the 8 and the 18. Yeah?
That helps.
Everybody good then?
That makes more sense.
27 and 28, now we finally get to those special segments. That's my fault. So in 27, does everybody see the proportion you would set up?
27?
Yes.
Sorry, what now?
What am I gonna set up for 27?
8 to 8 to X.
Over 10 minus X, or like 13.5 minus X.
13.5 minus x, right?
Yeah.
Everybody good? That's this one right here that we're actually jumped way ahead of.
It'd be minus X?
Yep, take 13.5 minus x,
Because it's subtract 13.5.
because 13.5 is the entire thing, and I only want the little part, or the bigger of
So
the.
if I need the little, if I need
How
the
would
little
you
part,
find out?
I don't know if I
It'll
need
be 8 over X.
Yep,
And so if you do 10 over.
So yeah, so let's say that was 10,
13.5
that's
minus
the little, that's the other line, so then use X and 10 on the bottom.
Then we can just subtract it and then you find out.
28, pretty much the same thing, right?
9 to, or 10 to W.
And then 9 to W minus 36, or 36 minus W again. So we didn't really have an example of the other ones, right? Meaning a median or an altitude.
So how would you set up 28? It'd be
28, I'm gonna do 10 is to W, so I'm using this principle right here. So I'm gonna do 10 is to W is equal to, what was this side?
9 over W minus, or
36
36 minus W.
I understand W, I cross confused.
So then I just have 2 W's in it.
Which
Okay.
then, yeah, you just.
So when we're talking about the median and the altitudes or the angle bisectors in the other aspect is when we had 2 triangles, right? So if we had one triangle like this and then another triangle that they said were similar, and then we had an altitude and an altitude, remember I can take this altitude, if this is 14 over 7, I'm going to say, and this is 10, then X is right over there. So I can do it to any sides that I want.
So we 10 to X equals 14.
What if X was on the other side?
Then I really couldn't do the problem,
It's impossible.
because I don't have enough information. If this X is over here, this 10 and this X are in the same similar side, so I can't do the problem. That makes sense?
But you would still do it though.
Because I can, no, I still can't do it. Okay? So again, it doesn't matter, so if we would have said then that this was 10 and this was X, now you could do it that way, right? Because then these sides are in the same spot. But again, they have to tell you that they are similar to each other, okay?
What was the other one besides the angle bisector?
An angle bisector, an altitude, and a median.
That's an altitude.
This is an altitude, yes. A median, you would have the little slashes on it.
Oh, then you just.
So for angle bisector, if it says just 1x, could you divide that by 2 then find it? So,
Say it one more time.
like, say the triangle is angle bisector, so it splits in half,
Are you doing this kind or this kind?
the first one.
This kind?
And then could you just divide that by 2 to get 2 bottom halves, or no?
No, because if this comes down, it doesn't necessarily divide my side in half,
That slashes you.
okay? It only divides the only way that's gonna happen is if it's an isosceles triangle or an equilateral triangle.
Okay.
Then it would split the side in half too. So that's a good question. Okay? Turn the page, you don't have to do the similarity ones. Then we go to our models. Okay? 34 is the first one I'm gonna look at. A popular scale for model trains is 1 to 48. If the actual train car had a length of 72, find the corresponding length of the model in inches. Which one's the model in the 1 to 48?
48.
The model.
Oh,
1, right? So I'm gonna do 1 over 48 is equal to what?
72.
X over 6.
X over 72, exactly right.
So you use the actual.
Okay? Make sense? Now here's the other thing that you gotta be careful of. No, never mind, it should work. In 35, now we're going to have the little chart basically on a map, right? And we're gonna use that. You will have to measure it again, okay? I know some people I don't honestly know what some people did on the quiz. You measured it, but that's all you did. You know what I'm saying? So you measured it and you said it was 2 inches. That was your answer.
I didn't,
Oh, so you convert.
But you had to put it back in and you have to convert it to the actual distance.
So how would you do that? So like 0.75, how would you convert
this
that?
is bad.
Say it one more time.
How would you convert it, 'cause it's 0.75, what's that, I don't know.
That doesn't matter if it's 0.75. Just put it into your proportion as 0.75. That's
Yes,
totally
yes.
fine.
No, it's like 0.75 equals how many miles or whatever, so how do you set it?
That's okay. Just put 0.75 inches is to 17 miles.
And then you put wherever you.
And then you go and measure it, so you get 2 1/4 inches, and then I'm looking for the miles.
Oh,
So then multiply.
So I'm just multiplying and dividing. You can leave it as
You wouldn't
0.75.
multiply across though, would you?
No, this is a proportion again.
Yeah.
So I'm gonna take 2.25 really, times 17 divided by 0.75.
I think that's what I did.
So the ones with the map is going back to a proportion.
You'll be, like, in those, like, the ones where you measure the map, that's like, you'll be converting
Look.
those, like,
Yeah,
you'll be converting from, like,
I was just.
inches, that to the feet to find how many miles it is, or like, you know what I mean?
Well, I'm not
Yeah.
converting them though, because this is a scale, so I'm not doing
But
a
in the sense,
conversion.
I mean, but in the sense more, I mean, because you have 2 1/4 inches, you're trying to find that in miles.
Over 7?
So
Yeah,
it's-
but I'm not converting it.
Would you?
Over 8 was 12.
The converting was when you were taking this scale and turning it into a scale factor.
What about 34? Would that, like what we just did, is that the one where you convert?
I think you just.
1 to 48, at times in inches.
0.75 and 7.
Yes, you could do it on that one, yes.
So 1 over 48 is.
I don't know if it's.
I think
it's.
I would probably, the first thing that I would do is turn
multiply it.
my feet into inches and 34.
No, you go 6 times 2.
But then you're just solving that like so.
I multiply.
Oh.
It's just solving for x, right?
Pretty sure that's what I
That one you are, yes.
Okay.
Okay? Did we get it figured out there, boys?
Yeah.
Gabriel Scott?
You got it.
He's just trying to figure out.
He's trying to work it out.
Yeah.
Alright. Any other questions? So the biggest thing is to make sure that you read the directions again, that you're putting things in corresponding spots. Meaning if I'm looking at the small one compared to the big one, it doesn't matter where you put them, right? Because everything has 2 scale factors,
Yeah.
but you just gotta be consistent. Okay? Questions? Several people in this class have more